This is a few days after having gotten my meter, and I now have some wire that I can use for testing the inductive part of the meter. So you can see from looking at this is 30 gauge wire. This actually feels pretty heavy, but you can see right there is 2.5 pounds. I went ahead and got this because this seemed to be the sweet spot as far as the price is concerned. The 5 pounds was too big, and whatever the size smaller than this was not enough. So I've already gone, I've looked up some properties on this wire, and I've written them down in this paper for the calculations I'm going to do. And just so you can see them, these are my two test inductors. For one of them, I wrapped wire around here like 20 times, and then for the other one, I wrapped wire around 40 times. So I'm expecting these to, one to have an inductance twice as large as the other. Not perfectly, because of course there's imperfections in how I wrap the wire. You can actually see it's kind of loose somewhere, and I don't know, that might end up having an impact, and the length of my leads, of course, will have an impact. Now, I'm not going to go into a lot of explanations for this calculation, but when I went and I tried looking up information, I did find this equation for measuring or for estimating the inductiveness. Now, I did have to look at some other properties, like with this being 30 gauge wire. I had to find the diameter of the wire, which was listed as 2.546. When I measured it myself with my micrometer, I get something that's fairly close but slightly different. That could be because of calibration issues in this, or it's possible that there's manufacturer variation within this wire itself. But we're going to go ahead and use the listed value for the diameter. And there's another property the wire had to get called relative permeability. And so for copper, it comes out to this number. It's easy to remember because there's 5 9s in there followed by the 4. As far as the loop diameter, and the loop diameter would be, of course, the diameter of one loop. I measured the diameter of the pin, and it came up to like 10.352. Once again, just consider that an estimate. And there's a number of variables that are going to go into this equation. So when I write the equation out, this is what I end up with. Now, when I put all these values in, this will tell me how much inductiveness there is in one loop. And to get the total inductiveness, I can just multiply whatever I get from here by the number of loops. So I'll be able to use the results of this twice. One's from my 20, from wrapping around 20 times, and the other one from wrapping around, what did I say it was, 40 times. So I'm going to go ahead and start putting this in. Yes, I am still using a calculator. This thing is, I don't know, it's probably older than some of the people that are looking at this, but it's old faithful. So I'm going to go ahead and start entering the calculations in. Okay, so here we have what it says is the inductiveness for one loop of the wire. Let me make a few copies of this number. So to get the inductiveness for the one that only has 20 wire wraps, let's take 20 and multiply it by that number. And so that's the inductiveness for the smaller one. And let me take this number again and multiply it by 40 to get the inductiveness for my other inductor. And so this is what it says my inductiveness should come out to. So I'm just going to round this and say that one of them is going to be 5 and the other one's going to be 10. So now let's see what the actual meter says. In the first part of this video that I put out, I did say that I was going to prefer to just connect things directly to these inputs, but with the thinness of this wire, I actually found it was kind of difficult to insert it in there. So I'm going to use my short leads instead. Okay, I've got it connected. Turning the meter on. I'm going to let it do its measurement. Okay, so on my smaller one, it is coming out to 5.4, it looks like. It looks like that's where it's settling. Okay, now let's try my larger one. At the very least, I'm expecting to show a value that's about twice as big as this one. So let's see what it actually says. Here we have the one that had twice as many loops as my first one. And so this one is coming out to 11. So I guess that's not too far off from calculations, where my calculations came out to 5 and 10. Of course, there's going to be some variation just in how I put that together, but with it not being too far off, I mean, I'm actually, once again, happy with these results.